Hello everyone, my name is Malik and you are watching Malik Robotics. So, this is our second video of manipulating our tensors. This is the probably last video of we are talking about tensors, and from the next video we are going to jump on what are neural networks and how to make the neural networks. So, without wasting much time, let's jump on to the video. Okay, without wasting much time, let's jump to our Colab notebook. Where is our Colab notebook? Let's make it what I say. Clear the output. Jump to the first code, and I think this is small. Okay. Okay. So as usual, first we will import our libraries. TensorFlow as tf, NumPy as NumPy. TensorFlow is the library which we are working on, and NumPy is the library which is good for mathematics. Okay. So let's start with our first topic, which is changing the data type of tensor. I've already taught you what are data types and how you can change the data type of normal tensors, like from float to int to other things. I have showed you in the other playlist that how we can do when we are using only non-machine learning or data science. In this, using TensorFlow, we will show in this video in using TensorFlow how we can change that data type. First of all, we will make a constant b. Wait, let's separate this so that we can have some easier look. Okay, here first of all we have created a constant 1.7 into 7.4. Let's see what is b. Okay, so we had a error like this. Then what we did, we converted in 32, which make it 1 and 7, like in 32. So it's this much easier. We just have to convert is like our tensor to int 32 by applying like in entering int values. But if you say that this is we are typecasting ourselves, means we are putting float here and int here, what the TensorFlow is doing for us. So here we will convert first of all float to float 16, like here b. What is b? B is 1.7 and 7.4. Okay, so let's convert this in float 32 to float 16. For here we will use our tf.cast. This function is used, and in this function we should apply two things. One is just the variable or constant, and then the type of data which we have to convert. Okay, so here you can see it is converted in float 16. After that we will convert int to float. Just this is the c, which is 1 and 7. We will just tf.cast and df type.float32. You can see we have got the float digits right here. Okay, just like this we can make it float 60. Okay, so we have converted integer to float and float to integer. So this is how you can convert other things. Okay, now we will have absolute value. For this we will use a function tf.abs. Okay, let's make a tensor tf.constant minus 7 and minus 10. Okay, now we will make an absolute value, means value without the signs, positive or negative signs. Here we got the absolute value. This is some easier. And now other things are min, max and mean and some functions of TensorFlow. For like to find a minimum value from an array, we will use tf.reduce underscore min function. For maximum we just replace it with the max, and for mean we will replace it mean and then in sum. So tf.reduce function are used for finding these four. Let's perform. Okay, so we have made a tf.constant. Okay, here we have used random function, which I have taught you in the previous video, where the values are from 0 to 100 and the size will be 50. So this is the tensor of say rank 1, and the size is 50. Okay, so let's find the minimum value. If you find a manually minimum value, I think 6. Wait a minute. Okay, it is saying that minimum value is 1. Okay, so here we have a minimum value of 1. Maximum value 98. So you can search this and we can't find anything above 98. Okay, so now mean. What is the mean? Mean we have to summation of this divided into total elements, means sum divided by 50. So if we divide 256 by, wait a minute, 2556 divided by 50, we should get 51.12. So this confirm that the mean is correct. Okay, now if what I say that I am your that chunky uncle, which say that I want a position, not a value. So for that we will use tf.argmax or argmin. So this will give the maximum element position and this will give the minimum element position. Let's create another tf.constant with a random value. Now argmax. Now this is saying that NumPy 22. Let's see, 1, 2, 3, 4, 5, 10, 20, 22. Okay, so according to this, the max value is 0.49. Sorry, 0.98. Yeah, okay. It will start with 0. So 0.98. This is the maximum value. You can see that 0.98 is the maximum value, and on the minimum value, the position is 15. So like 5, 10, 15, but it start from 0. So this is the minimum value. Let's print some statements. Or let's print this in some strings. Okay. So our maximum value is at 22 and the max value is 0.98. Right, we just saw it by calculating here. Okay, now what is the squeezing of tensor? We will squeeze the tensor. Squeezing means to remove all the dimension. Like for squeezing, we will use tf.squeeze. Okay, let's make some random tensors. This is the 5 rank tensor. Let's squeeze the value. You can see that tf.squeeze function make the what I say the rank to the 1. Okay, now we will see how we can square, log and square root. Let's make a h which is an array from 1 to 9. Now we just have to tf.square, so this will make the square 1 to 4, 2 to 4, 4 to 9. Now tf.square root. Okay, remember I have written here also this tf.square root can only be done on the float digit. So here we got some error because we give it an integer value. But if we type cast it to tf.float32, then I think it should work. You can see that we get the square roots of the h. Okay, now we can have some log values also. This is how normal mathematic manipulation done. Now we will manipulate some tf.variable. Till now we were doing on the tf.constant, which can done also tf.variable, but tf.variable have some extra functions, which is dot assign and dot add assign. Okay, so for dot assign, it's just we made a variable from 0 to 5, right? But I want to change the value of last value from 4 to 50. So we will use this assign function. I dot assign 0, 1, 2, 3, and 50. So now our I will convert it to 50 because it is tf.variable, so its value can easily be changed like this. So what I say, I want to add 10, 10, 10, 10 in each. So just I dot assign add and 10, 10, 10, 10. Now what we got is just 10, 11, 12, 13, 60. Okay, so this was all about adding and subtracting square roots and maths functions. Now for maths, the perfect library is NumPy. Okay, we have seen in previous video how can we make an tensor from NumPy, but we can also convert tensor to NumPy like we made from NumPy to tensor, so that we can use some NumPy actions on the array and then convert it into tensor to use in TensorFlow like this. For creating a tensor from NumPy, we just have to give a NumPy array and then we can use it tf.constant and it is made. Okay, but now what we want to make some NumPy uh, functions on these, so we have to convert it from NumPy TensorFlow array to NumPy array. For that, we just have to use np.array to j, just like we use tf.constant to the NumPy array. Okay, and else we can use just dot NumPy like this. We can also create a NumPy array like this only. Okay. So these are some practice questions. Like it's not the practice question. We are just converting NumPy to TensorFlow, then TensorFlow to NumPy, and then their float like here. Okay. So in first we have a NumPy array. In second we have a normal array. We are both converting using tf.constant, and we get tf.float 64 and tf.float 62. Okay. Now, last but not the least, in this video, we have tf.function. Okay, in what tf.function does? Like this is a normal function which return x into 2 plus y. Okay, and this is the function with tf.function decorator. Okay, now you will say that Rudy or rhythm, the function with the decorator and the function without decorator are pretty much same. I will say, yeah, you are very much correct that these are the same. But what will happen in the backend is different. Like if we are using tf.function, then it will render it like a TensorFlow graph, which increase the speed, and you can easily deploy to other things when you are using tf.function. We will talk in much detail in the like deploying section. Okay, for right now you just have to learn that you have some tf.function which increase the speed of the function. So this was all about tensor manipulation 2, and we have finally come to the end of the normal tensors manipulations, and we can finally move on to the regressions part. So without wasting much time, let's meet in the next video. Until then, bye bye.